Hello and welcome back. In this lecture, we learn about the concepts absolute pressure, gauge pressure and vacuum pressure. To better understand this concept, let us quickly review the concept of atmospheric pressure discussed earlier. The atmospheric air roughly extends to 10.3 km from the surface and it weighs nearly 101 kN per square meter on the Earth's surface. The pressure exerted by this column of air on the surface of Earth, P2, can be calculated approximately as 101 kPa. Please note that in this calculation, the reference pressure P1 was absolute zero. Therefore, the atmospheric pressure 101 kPa is absolute. The atmospheric pressure measured with respect to absolute vacuum or zero pressure is 14.7 psi or 101 kPa. For example, consider a pressure P1 higher than the atmospheric pressure. If this pressure is measured with respect to absolute zero as reference, it is called absolute pressure. Now, consider pressure P2 less than atmospheric pressure. As we discussed earlier, if this pressure is measured with respect to absolute zero reference, this is also absolute pressure. However, fluid pressure can be measured with respect to atmospheric pressure as reference. If the pressure is measured with respect to atmospheric pressure, it is called gauge pressure. Gauge pressure measured below atmospheric pressure is called vacuum or suction pressure. In this example, pressure P2 is vacuum pressure. A pressure gauge is used to measure the pressure of air inside a tire. The gauge reads 35 psi. Calculate the absolute tire pressure. Given that the standard atmospheric pressure is 14.7 pounds per square inch or 101.3 kilopascal. Since the gauge reads gauge pressure, it is measured in reference to the atmospheric pressure. Therefore the absolute pressure is 35 plus 14.7 equals 49.7 psi. A vacuum pressure gauge as shown in figure is connected to the suction line of a centrifugal pump. The gauge reads 20 inches of mercury vacuum. Calculate the absolute pressure. The first step is to convert 20 inches of mercury to Pascal. For this we can use an equation connecting pressure at a location of fluid to its density and pressure head. Since the reference pressure is atmospheric, the vacuum pressure is minus ρ GH. Density of mercury is 13,500 kilograms per meter cube. Finally, the absolute pressure is calculated as 34.1 kilopascal or 4.95 psi. The systolic and diastolic pressures are measured as indicated for a human being. Calculate the absolute values of same in psi and pascal. We will solve this problem in class. Finally, the summary is that, for pressures measured above atmosphere, P absolute equals P atmospheric plus P gauge. For pressures measured below atmosphere, P absolute equals P atmospheric minus P vacuum. I hope you have understood these concepts. Thank you for listening.